In a world where space and time are intertwined, one man dared to challenge the status quo. His name? Dayton Miller. His weapon of choice? A flute. But not just any flute. This instrument held the power to unleash the ether, a pervasive medium once thought to fill the universe. Miller, a physicist by trade, a musician at heart, discovered a harmonic resonance within the ether. He found that his flute, when played with precision, could manipulate this elusive medium. His melodies, a symphony of science, had the potential to shift the very fabric of reality. However, a sinister force lurked in the shadows. The Einsteinian demons. These creatures thrived in the distortion of space-time, causing chaos and disruption. The world needed a hero, and Miller was ready to answer the call. With his flute in hand, Miller played a tune that echoed.
All right, hello and welcome. We are live tonight with Dr. Michael Heffron, the founder and CEO of Celestial Theodolite Internet. I'm just kidding. He brought us the Celestial Theodolite. So tonight we're going to be going over a recap of the Celestial Theodolite and some of the arguments that have come about to try and call it into question or refute it. And Mike's going to give us an update on that. So a quick recap on the Celestial Theodolite is using mountain terrain or buildings or whatever physical obstruction you can come up with to intersect with a star at a specific time, and knowing the elevation angle of the object you're using to intersect and the timing that the star gets occulted by the object or occluded by the object, you can determine that the angle to that star. And with that, you can differentiate between the globe and in a flat Earth prediction, which have mutually exclusive angles. And we're going to find that the only way that the globe exists is through refraction corrections that don't have any significance in reality. When the star gets occluded at a specific time, you know that is the true position of the star, and that object occluding it has that true elevation angle to do that, because it's not going to be occluded by a mirage, right? Okay, so to recap, starts with a null hypothesis scenario where we have the Earth is a globe and then the Earth is not a globe. So we go through these two mutually exclusive predictions with Pikes Peak, and this website here, movabletype.co.uk, is an amazing resource. Everyone should have this bookmarked. Or, copy link. Have that. So using this, you can you can get all the necessary information you need to make your own predictions. Because as it's going to turn out, the way that this works is you don't necessarily need an accurate theodolite to make these measurements. You don't need anything like that. You can just use the timing and the elevation angle. And the elevation of the object to determine the angle. But if you want to, get the measurement on film or whatever and do that, by all means. But the angle is confirmed at the time of occultation. So anyway, what we have here was Pikes Peak at a distance from 50.7 kilometers, which creates a theta angle of 2 degrees and 31 arc minutes for this elevation, or for the top of Pikes Peak, which has, what was the second? Anyway, what was it? Pikes Peak is like 4,000 meters or whatever, but then wherever you're at sea level, it comes out to be 22, 26 meters there. But anyway, that gives you the angle there. And then so if a star, you can pull up Stellarium and then pick a star that's going to intersect at this angle here. and if it gets occluded at that time, then you know that that's the true elevation angle of that star. And oops, what Mike did and what Shane reproduced was opening up Stellarium, which I should have had ready, but I don't. Stellarium.
So 39.
So what you'll do is you'll you'll enter your coordinates. You'll enter once you have your position of where you're going to be doing your observation, you pull up the star, and then you get the where it's going to be for its elevation angle. So the alt as what it comes out to is 2 degrees and 32 arc minutes. So for the star selected, I think it was, what was it, Aquarius or something like that. At this specific time, that star is going to be at 2 degrees and 31 arc minutes. So you're not going to see in Stellarium like the mountain peak or anything like that occluding it. You're just going to get the angle of where it's going to be. And then in reality, if at that time you're observing that star, it gets intersected by that peak, then you have confirmed the true elevation angle of that star and this mountain peak. Does that about give the summary, Dr. Mike?
So that's pretty close. There's a few nuances I would say slightly differently, because really you could film the peak blind and not even know what stars are being occluded. And if you see the stars being occluded and you've got the timestamp for when the star disappeared, you can actually look them up in Stellarium after the fact.
Oh,
So,
wow.
so
Yeah.
truly, Stellarium will tell you the angle after the fact that you just saw occluded, and lo and behold, it does always end up to be, in this case, for Pikes Peak from my house, it ends up to be 2 degrees 31 arc minutes every time.
I thought it was neat that when you're in Stellarium, when you turn atmospheric refraction on and off, because it's a nice easy button on the bottom, you can see the prediction literally dance from globe to flat from the two numbers, like almost exactly, right?
Yeah,
Because
and they were really sneaky about it. I'm not sure how adequately I pointed this out to everybody, but they split the correction, half on the peak, half at the observer's location. And it's when you put the two of them together to give the globe prediction. When you use their theodolites marked on the ground somewhere, they're only giving you half the correction. And they manipulate the numbers a lot. But the cool thing about this technique is you could drop somebody off in the middle of nowhere and they don't even know where they are, and you just have them time every star they see occluded by the peak, and then this could be a double-blind study. Somebody else looks at the data, knowing where the peak is, and verifies the angle, and whatever the angle should have been between the observer and the peak, that's what it turns out to be every time, as long as all the globe Earth corrections are turned off.
Incredible. So basically what that means is the angles to the stars, like the backbone of Stellarium, is built on flat Earth elevation angles, and then they have a uniform refraction correction that they can apply to turn any observation into, well, this is where the stars should be based on globularity.
Yeah, I always thought about it like they took just multiple observers with their alt as grid. So just like, someone using whatever portion of the sky they could see, taking an elevation angle off their flat baseline anywhere on Earth, call it like a latitude dependent sample set. And then from there, you can construct the celestial sphere based on that latitude dependency going in inverse. And then that's why they have constant refraction corrections to bring everyone towards that, that third party orthographic position where they pretend that all the stars meet at, right, for all the different observers all over Earth.
And
I got a-
I think more.
Oh.
Oh, go ahead. Go ahead. Ask your question.
Yeah, so does it matter what type of refraction correction formula they use?
It would matter, but they appear to be using G.G. Bennett's, which is apparently one of the more accepted celestial refraction corrections. And what I was going to say is I'm not sure Stellarium realizes that that's what they're doing. They have a really good star database, and they keep track of where the stars are. And I don't think they even realize that when you turn on atmospheric correction, it's actually warping everything to agree with the concept of the globe.
You think it's unintentional, really?
It's very
On
generous.
Stellarium's, yeah, I am being generous. On Stellarium's part, I'm giving them the benefit of the doubt. And fortunately, astronomers demanded to be able to turn it off because atmospheric, as we all know, atmospheric correction is hardly ever correct.
Yep. They have a standard, they have a gradient, they have 7/6R following the natural curve of the Earth based on the radius value. They have Gaussian coefficients ranging from 0.13 to 0.14, depending on, they should be depending on height and elevation, but they're not. They just name it 0.013 across the board for all and every observation. Craziness.
Yep. And then for good measure, they threw in temperature and pressure correction to make it look legitimate.
Oh, yo, Alan, right? So speaking of corrections that fix the globe, you see these two things I put in chat? That first chart was from the 69 miles per degree map out with some basic trig and the 59 distance. And then the other one is the refraction correction that from Mike's presentation over here. And you can see that one would correct the other, right? Crazy.
Yeah.
It's like, look, it fits like a glove or whatever.
They got a nice little logarithmic scale there.
For optically trying to deduce star distances based on how far it appears above the horizon. And then, it gets towards the horizon, things get a little sketchy. It's okay because you can apply hefty corrections right at that point and everything works out.
So I got one more question then. If it doesn't matter what refraction formula they use, is that because the flat Earth prediction using simple trig is enough to figure out when the star gets occluded by the mountain? So like you say in your presentation, you can use a mountain like a crosshair essentially.
Yeah, that's true. So, and I think what they do is they pick whatever correction they need to convince somebody that it's legitimate on any given day, because what I've been noticing is their corrections vary from day to day, from person to person, and it's like every person is picking out whatever correction they think makes their case.
That's the beauty of refraction. It always was. Some guy named Walter Bislin made a refraction quote calculator that would expertly, all right, what was your observation from how far away? Here's how much refraction we need to make it go away. That was literally the math behind it, and it was so obviously clear. And then it was like, oh, so no matter is there a distance that we can make an observation where you wouldn't be able to use refraction? And they just always say no. And then we're like, oh, well, then this argument is silly or whatever. That's just how I feel.
And the way they hide what they actually did is everybody notices that as the angle of elevation gets smaller, the correction goes up almost exponentially, not quite, because they cap it at a certain value. That's where they hid the fact that it's really predicting the shape of the globe. And they justify that by saying, well, it does small angles, it has to go through a lot more atmosphere, so it gets reflected more. And it sounds very plausible until you do the math yourself and realize every time it's just turning a flat Earth prediction into a globe Earth prediction.
I like how you said that. That's very crystal clear. On the other side, if you do like the 69 miles per degree argument, like if you're going to take linear distances based on, say, a celestial precession or whatever, the degree the relationship is on the surface of Earth for precessing 69 miles or whatever, if if you're going to make that apparent, then they call it linear, but it can't be like partially linear. It can't be like somewhat linear at the equator and somewhat linear when you're just at the horizon, and somewhat linear when atmospheric refraction is there, and linear all the rest of the time. No, it ends up being linear most of the time, and they correct for all the times when it's not. But as a thing that needs to be linear for that, to make sense geometrically and mathematically for the globe, it's kind of funny because, you can just say, well, if it's, if you're at the equator and you're at negative whatever, just one south past the equator, and you're looking at Polaris, what's the linear equation that you can predict that will give me like the elevation angle? Like, no, you shouldn't be able to see it, so you need to invoke refraction immediately, and that just breaks it right there, I think.
Someone just brought up how they will claim refraction gets more advanced towards the horizon. Do you think there's a way to take like the angular difference between two stars, like near vertical, like 90 degrees from the horizon, and then later, like that night, measure the angle difference between the two stars as they approach the horizon? Like basically, maybe the star that was about to be occluded, you take the angle, back towards 90 degrees from that star you measured earlier, and then you could actually try to define what the effect of refraction is. Y'all think that that's maybe a good idea?
Well, I think Ken had the best solution for it. He was like, show me the equation that'll predict how much refraction there'll be on before I make this observation, and then we can prove it wrong. But the fact that it's unfalsifiable and they'll never be able to do that, they can only do it in reverse, says everything, right?
They always do it post hoc.
Yeah, always after the fact, never beforehand. Therefore, it can't make predictions. What does that tell us, right?
So I do have like a question for Alan. Like, what do you just present? So I know I just came in a few minutes ago, so I probably missed like the whole presentation, and I'm sorry for interrupting the last presentation. But like I've been thinking about, shouldn't there be a time where you could predict in advance when the star will be occluded, and then you could use like some sort of like chronographer, like the super accurate time, like the clock, and measure when it actually is occluded. And then if it doesn't match the prediction for the globe, then you could falsify the globe. Is that what you're basically discussing just now?
Yep.
Cool. So I have like an idea for this, because this summer, Ken and I are supposed to be going to like Salt Lake or whatever, and then like throughout all that time, we ought to be around like mountains and stuff. So maybe we could try something like this. Like, so measuring refraction with the two stars, that kind of seems like a good idea. But I have another idea too. I want to run by all y'all. Like, what about how the star moves in the horizontal plane? Because what we see, and basically what I've seen from like all the star trail videos and stuff, all the stars are moving in a circle, sort of like in an arc above you. Is there some way to kind of measure on the horizontal azimuth where the star is? Maybe, I mean, I don't know, from one horizon to the other, that sounds like it would take a really long time. But like from 90 degrees above you to like where it's at horizontally, is that something you can use to show a circular star path to support flat Earth? Or, if it's going more of a straight line, that supports globe or something. I don't know.
So flat Earth and globe Earth are both using the exact same coordinate system, and so there's pretty much a one-to-one correspondence. The trick is the refraction corrections the globe Earthers throw in, so that after the fact they can say, "Oh, that proves it's a globe Earth." So what you've got that they don't have is you don't even need to know where you are to watch a peak occluding stars and get the exact timing when the star disappeared. And if somebody else knows where you are, they can predict what time you saw the occlusion, or they can take the time you saw the occlusion and they can look up the angle and they'll see that it matches the flat Earth prediction, and it never ever matches the globe Earth prediction. And their predictions are all over the place anyway, but even if they could come up with a valid prediction, what it's telling you is their prediction is wrong. It's saying you're on a flat Earth, you're seeing that star in a straight line of sight according to a flat Earth prediction, and it's not the angle would need to be if we were on a globe Earth.
I really love this experiment. Like, I can't wait to try it out. Well, I guess oh, sorry, what?
I was just going to say the first time I ever did it, that was fun, and it's just been getting more and more fun since then.
Definitely. Like, what about, does it matter about the horizontal azimuth that the star is occluded at? Like, I guess one thing that I might foresee a glober arguing was, like, how do you know it's going to occlude at the direct tip of the mountain? Or if it's not going to occlude at the tip of the mountain, how do you know the elevation at which it was occluded?
So on Globebusters episode 13.6, I explained how to do it, and that that website that Alan pointed out. Let me see. I'm looking for the movable type.co.uk website that he pointed out. That one tells you from wherever you're observing to the peak what the final bearing is. If you set Stellarium or your favorite astronomy tool to that final bearing, and then set a cursor that is centered on that bearing and your flat Earth predicted elevation for the star, that will show you exactly where the peak is going to occlude the star.
So, like, even if it's kind of off to the side of the very peak, it shows you, like, at which point on the mountain it's going to occlude the star?
It does, and it does that because it again, this is with atmosphere turned off, so you want no atmospheric refraction correction, and it shows you the actual path of the star, and it's the actual path of the star that causes the occlusion. So the globe earthers, they want to tell you, oh, well, the star is refracted, so it appears to be someplace different than what it is, and that's what you have to pay attention to, and they're dead wrong. What you have to pay attention to is where the star actually is, because they're trying to tell you refraction is changing the apparent position of the star, and that's what you see. And they're wrong. You're seeing a straight line of sight to that star, and all of their hocus pocus corrections are to make it appear to be on a globe Earth instead of a flat Earth.
Okay, I guess one last thing was, like, what about well, you already said, like, the app shows you, like, at which bearing it's going to be occluded at, but what were y'all's thoughts on, like, tracking its bearing movement from either one horizon to the other or from 90 degrees to the horizon? Like, have we found that the star will move, like, kind of in an arc path or something? You know, that's what I would predict, like, with the flat Earth, I feel like.
Stellarium
It's
or
gonna look
any other
the
tool will show
exact
you the path.
same. Yeah, it's not gonna do anything different.
Like, what you mean? Like, it's going to go in a straight path, or it's going to go, like, in an arcing path?
Arc.
Yeah.
It'll be an arc one way or the other as long as you're not on the equator. But the nice thing is that once you told Stellarium what peak you're looking at, it'll show you, and you have correction off, it'll show you exactly what the stars are doing. And if you can get your cursor defined so that it shows you the right place on the peak, or do that with tape on your screen or something, you can predict where on the peak it's going to hit.
That's super cool. All right, thank y'all.
Yep. Yeah, Shane did I'll send you a link to it, but he did a clip of it live on Globebusters on Sunday. So you can go through and do it yourself. And then I'll send you that website as well.
Okay, thank you.
Yep. All right, cool. So the other part about this is that the arguments about where the star is after the fact, right, are completely irrelevant, because that's immediately where everyone took it. They were like, but the star is behind it and it's raised up. We have to do all these corrections. None of that matters at all.
And that's where they want to keep steering this. They want to say, oh, there's no way that can work. You have to make corrections. And they are doing their best to make everybody believe you have to make measurements, you have to make corrections. And no, you don't. You just have to know what time did the peak occlude that star. Look it up in Stellarium, it'll tell you the elevation. And once you know what Stellarium says the elevation is, you can then compare that to flat Earth prediction versus globe Earth prediction. And what you will find is every time it matches the flat Earth prediction, and you'll also find, despite what those globers say, they can't even predict it. And they can't compensate it enough to make that angle, because as soon as they've got that angle, they've just turned their globe Earth prediction into a flat Earth prediction.
It's one of my favorite parts. Your position has become my position now.
I heard people the other day arguing that the light would be bending in two different directions, and they really had, qualms with that straight angle from your house to the tip of the mountain, and from the tip of the mountain to what Stellarium was saying. And I really am curious, is it easily accessible, that the top of that mountain? Like if you wanted to redo it and have somebody on the phone immediately take an actual measurement from the top of the mountain while you're doing it from your house?
That's easy to do. The peak is easily accessible. You can see it from all over the Colorado Springs area. I'm outside Colorado Springs in the country, so I have really dark skies here, and I can see it extremely well. It's a little harder to get measurements as you approach the city because of the light pollution, but you could do it on top of the peak. But the point is, if you get somebody on top of the peak measuring it, and they are going to have to deal with atmospheric correction, because atmospheric refraction is real. It's just no two people seem to agree on what it is, and so their estimates are all over the place. And that's how they're tricking people. They're saying, well, if you take this temperature into account and that pressure into account, and and some of them want to throw in relative humidity and this, and basically what they do is throw in enough corrections that what they say is not falsifiable. The beauty of this method is nobody has to measure anything. Stellarium will tell you what the elevation is, and it's always the flat Earth elevation.
Yeah, I think this one's particular, JT, because those two things, like, I think that's beautiful because the refraction can either apply to both of those or not to both of them, and they need it to apply differently, as you just outlined. They were like arguing that light should bend differently for each circumstance, and I think this particular example is great because it's much harder for them to refraction their way out of it when they have to do it like in two different directions at once, right? Because of the star and then the mountain itself. Like, how can refraction be moving the mountain but not the star or whatever? I think that's why it's a great point. That's why
Yeah, that makes sense.
they're
And
confused by the whole thing.
I always try to think about things from all angles and all possibilities, and I'm like trying to combine a laser test with his observation. Like, how could you shoot a laser from the top of the mountain straight back to his yard, and also have a laser shooting out the backside level, and angle it up? I mean, I'm just trying to get rid of
Completely
the arguing.
unnecessary.
I know, right?
Yep.
Yeah, and if you did that, refraction would apply both ways, and so then you'd have to start making refraction corrections. So if you read the PDF, you'll see what great care I took to make sure that refraction had no bearing on any of this. So I figured out how to completely eliminate the need of any refraction uh,
Ooh.
correction, and that leads them to a conclusion that they think is impossible, that you've got a straight line sight to the star that doesn't need refraction correction. And the reason that happens is they don't understand Snell's law. They don't understand, for all practical purposes, when you're looking straight at the star and seeing the peak occluded and it matches the straight line angle you predicted, what's happening is what's happening effectively is you have a zero angle of incidence. So yeah, it refracted as it entered the atmosphere, but you're looking at um, the waves of light that are headed straight for you with zero angle of incidence and therefore needs zero refraction correction.
Wow, yeah, I need to read the PDF. I've been super busy with preparing for our new little one to arrive. What angle were you from your front yard to the star right before it occluded the mountain? What angle is that?
I actually have no idea because after that my first measurement with the 8300, I never measured the angle of elevation again. Because by then I realized they're just going to explain, no matter how accurate your measurement is, they're going to explain it away with, you need to make this refraction correction or that refraction correction or this correction for temperature or that correction for humidity. And no matter what you do with a precision measurement device, they're going to argue that it needs correction. So that's when I put all my brain power into how do you eliminate the need for the correction. And so the first thing I came up with, well, if you watch the peak occlude the star, that eliminates the need to know what the refraction is between you and the peak. And then after I did that, I searched around in Stellarium on the peak for a while until I figured out, oh, the uncorrected elevation of the star tells you what that elevation angle was every time with no correction. So those two things put together, you know the exact elevation of the star predictably, and will always agree with the flat Earth prediction. And I was really excited when I tried it on Blodgett Peak, and it worked there too, because that's when I knew beyond a shadow of a doubt, yes, this works every time for every peak. Um, and you never need correction for refraction because you've effectively eliminated it by the star being occluded. Told you it's just below the peak. No matter where it appears to be, it really just dipped below the peak. So now you set Polarium to look at the peak and you ask it, what was the elevation of the star at that time? And it'll tell you, yep, that's the elevation you just saw. And it's going by the actual location of the star that observatories all over the world contribute to um, the precise location of that star. So you don't have to observe where it appears to be and then correct it. It's telling you where it really is, and you don't need correction.
Yeah, that's amazing. Thanks for fielding my question. Last thing, I'm just thinking this thing through. If the star was way up in the sky above 15 degrees, there would be no quote unquote refraction messing with it. As it gets closer to the ground, they always want us to believe refraction makes everything correct for their globe model. It's always the fix, it's always the band-aid, and they backwards, derive it. Oh, this is how much refraction made that happen. But I like Nathan, pitch lumens. observation on the ice with those 4 different colored lights at different distances that all show at the same level. And, that's another one where it's like, oh, so you're telling me refraction magically puts this all right at the horizon line? It's just pretty ridiculous, but I really appreciate how careful you were with that. And I look forward to reading the PDF later. Thanks a lot, Doctor.
My pleasure.
I wanted to ask, is it possible to get Stellarium source code? I was looking around because I was thinking ahead. Perhaps this might be revolutionary, where they might maybe this is thinking too positively, but would they possibly say, "Hey, oh, we Stellarium made so many mistakes, and thanks to Dr. Heffron, we have to make some adjustments because the source code was copying the wrong global Earth data, where they just make slight adjustments will be just outside the margin of error." Perhaps that's too much of a a revolutionary step. But is there any way to get the source code or?
So from what I understand, Stellarium is open source, and we can only hope that they try that because they will have astronomers all over the world complaining, "You just screwed up our star map. Nothing's where it's supposed to be anymore."
Definitely, definitely.
Yeah, definitely public, dude. It's all open source stuff. You can download it right now. You can mess with it. They have mods you can do. They have scripts you can run. There's a GitHub repository for custom scripts that people do for programs, for eclipses, demonstrations, models, all sorts of cool shit. Honestly, I love Stellarium. I have never found it to be inaccurate about anything. Except with that pesky atmospheric refraction correction or whatever, Got to be careful.
So
Yeah.
I share Shane's experience. I've never seen it be wrong until you turn on atmospheric correction, and then it's practically never right.
I didn't even
Now,
realize that.
that's an overstatement. It's only wrong near the horizon, and that's how you know this was intentionally designed to make a globe Earth look like a curve Earth. What they did, and I kind of say this in the PDF, but what they did is they say, well, every intelligent person knows the Earth is a globe, and therefore we have to correct it so that it shows the curvature of the Earth. And they seem to be totally unaware that they falsified all the refractions to make it appear to be a globe Earth. And there again, I'm giving them credit that this wasn't malicious; it was just stupidity.
Yeah, why attribute to malice what you can to ignorance, or something like that. I think I butchered it.
Right. It's always better to attribute to the ignorance than to malice.
Except when they're a bunch of malicious dickheads, but whatever.
But when you know they're slimy, globe-eyed reptiles, maybe you
Reptilians, yeah,
want to assume
exactly.
they're malicious.
No, who said it was open source? Yeah, Xavier. They're not going to change it. I don't think it's been like this forever. So I think anyone can like do mods and stuff. The amount of stuff you can do with Stellarium is actually staggering. Like if you just look into it, you can download scripts that people wrote. And it's like, oh, show me. I want to model the eclipse of, say, I don't know, 2028 in Australia, right? And you can watch it from the viewer perspective, and it can give you all the data. You can watch the moon's mass flicker as it gets bigger. They literally pretend that it changes mass because of its luminosity, but that's something else. Stellarium is pretty great. I recommend it.
Nice. I'm definitely gonna start using it. Thank you.
But I just realized I always turn atmospheric off as soon as I open it. The first thing I do is just turn the atmospheric off, and so usually for what I'm doing is I turn all that crap off, and I didn't realize what a good experience that led me to have of it always being accurate. Yeah, like if I try to use it in arguments, people would just be like, "That's a globe, dummy." And I'd be like, "Okay." Well, they're definitely modeling a celestial sphere from a local alt as grid and then doing a coordinate transform, from celestial to local to portray what is an accurate celestial map on your local as grid. But whatever. Sure, it's globe. Even the term azimuthal grid came from playing around with that, because I was like, what do you call it when it's this local sort of partial view of the sky that seems governed and limited by a thing? And it was like, oh, it just calls it azimuthal grid. It's like, hey, what's it? Look what Stellarium calls it. There you go, azimuthal grid of vision or whatever.
Hey,
Yo, Shane, you want to walk us through a Stellarium run of what it looks like to make the prediction?
I was just about to ask, can we see it with Stellarium? And top of that, Dr. Mike, if you're still there, what do you say to people like Ruhif, the Australian reptile, who say that your elevation matters because if you don't put in the right elevation, then Stellarium is going to give you the wrong prediction?
He has no idea what he's talking about. I told him when he was spouting his nonsense, you don't understand. And he was trying to convince me he did understand, and I never said another thing well, I think I said one more thing to him afterwards later about something, but I just quit communicating to him because it was clear to me that he totally failed to understand what this was doing and how it was doing it. And I think it's because he's in denial. He cannot conceive of the fact that the data shows the earth is flat because he so firmly believes it's globe. And that reminds me, Shane, of something I'd love to see added to your celestial sphere model, and that is a satellite eye view through a fisheye lens or whatever it takes, so that you can see as that lens is traveling over the flat earth, that's what turns it into the appearance of a globe. Because since I've seen the satellite data real time, I know that it does appear to be a globe from Earth. But the reason I think that's happening is the light is truly bendy, and everybody knows that black holes have gravitational lensing, and they're probably arguing about the degree to which that happens. But when you look at my Luminiferous Ether book, actually even the scientific method book, you realize we are living on top of a black hole, and it's got to have gravitational lensing when you get far enough away from the surface.
Huh. So you think it looks like a sphere, but that's an illusion of light bending? How far away do you have to think do you have to get before it looks like a sphere, do you think? Or do you think just the coordinate system in which the satellite routes are portrayed is perhaps spherical instead?
Well, since I was involved in satellites for a long time, we all believed that the orbits they were telling us they were in were real, and they project them on various types of maps, and it always looked real. But I think that's because everybody involved was assuming the Earth is really flat because we're launching things into space and they're orbiting and they ought to be in the orbit we think they're in. How could it be anything else? And um, and you look at all the misinformation about black holes. Uh, Dr. Bennett thinks they should be called vortexes instead of holes, and I think he's probably right. And then I think they shouldn't even be called black because Hawking and Schwarzschild and everybody who came up with this stuff, their whole assumption was the gravitation is so strong that light can't escape from it. But if you look at um, the, the software for my ether model, and you can find that on GitHub under Dr. Mike Heffron. You can get. I wrote the software in JavaScript. I wrote it in Python. You can pick either one, and you can play with that, and you'll realize we are living on a black hole, and every atom in our body, if atoms are real, are black holes themselves. because they all conform to Kepler's third law, and it's when velocity defined by Kepler's third law reaches the speed of light, that's the radius of that subatomic particle or that planet, whatever it may be, that defines the gravitational parameter for that satellite or particle or planet or galaxy. It's pretty simple stuff. Everybody misunderstands it. So I think maybe a better name for black holes is luminiferous convergence or something. That's where everything drains back into the ether, but it doesn't gobble up everything around it. That's just a drain where all the ether around us that's not fashioned into particles is draining. Sure,
The old the old ether convergence.
I've been a fan of ether for as long as I can remember. Matter of fact, I spell it A with a slash and then ether. I've been spelling it that way for a while and getting a lot of hate. With like, why do you spell it that way? It's like because people don't know how to spell it. It's either aether or ether, and so I just do both with a slash. But Shane, and I sent you a friend request, so if you can accept that, that'd be dope. Thank you.
Yeah, well, you were asking about like the constellations, and that's a video I did with the flat Earth projection of like a Mercator star map and what it would look like, outlaid over a flat Earth. And literally, what you find is the zodiac constellations are visible from everywhere, all over Earth, because they occupy the middle band of like the tropic gap, but in the sky. So if you see like half of the sky at any point, or you have the radius of 3959, then there is no place on Earth you cannot go where you cannot see most of the zodiac, and I think that's why they have like astronomical. Yeah, significance. Yep.
I wanted to see
But
the whole thing. I was I'm a Virgo, so I've seen pretty much like 75% of the constellations or the horoscopes. I mean, and but Virgo was like hidden. Half of it was hidden right around the horizon. So I had to apparently travel to California, and even then, it was still a little hidden because of light pollution. So I will definitely watch that 5-minute video that you sent me, and I already shared it to some of my groups.
nice. It's a good one. What's the name of the star, Dr. Mike? I forgot.
The star that I presented,
Yeah.
39 Aquarii.
Yeah. What do I do with this? I gotta figure out how to find it. No, it found it and named it some other weird thing, and then I saved it wrong. So hold on, let me find what it's called.
Nice. While you're looking that up,
30.
somebody had the question: what's the minimum distance to the mountain that this should be used at for like an effective prediction?
I'm not sure there is a minimum distance. I don't think you can be. Probably if you get too close, it'll start being off because it's not really being occluded by the mountain. It's being occluded by rocks around the mountain. I suspect probably from 10 or 20 kilometers away, you'd probably still get pretty decent readings.
Okay. Thank you.
And I couldn't find your address, and I couldn't figure out how to DM you. So what I did instead is I just put a message in the main chat of where to find my author page, and the author page lists all the books. And if you have Kindle Unlimited, all the books should be free.
Yeah, but I want a physical copy of it.
So the author page will show all of them have physical copies. They all have paper book backs, and the Lumina Fifth Ether even has a hardcover.
Ooh, hard copy. Hell yeah. All right. Well, I'm definitely going to be buying your book, good sir.
Thank you.
All right, I got it. January 31st, 6/27/25. January 31st, 6/27. That's this, right? I get my location right. Over here. Right.
So it's the luminiferous ether, the primary substance of the universe. Dr. Michael?
Sorry, I forgot to turn my mic on. Yes, that's correct.
Okay, cool. I'm going to check eBay to see if there's a cheap version of it, but if not, I'll just buy it off Amazon.
Hey, Alan, is the presentation of this observation or this test on your channel from like a week ago or so? 'Cause I want to send it to somebody that hasn't seen it yet.
Yep.
All right, thanks.
Yeah, if you want
Evening.
if you want a nice clean hole prezi, the Globebusters episode, what was it the week before last was Mike laid out the whole thing.
Perfect. That's what I'll grab. Appreciate it.
Mm-hmm.
Hey, can I ask a question?
Absolutely, Taylor.
Is there any of that non-existent dark matter or dark energy they have for sale on Amazon?
Ooh, I should sell some. People would buy it, right?
Just sell dark matter in a milk carton, Taylor, and you'll make some money.
I discovered some of that in my backyard last week. Maybe I can make some profit of it.
I think one of those location parameters was a little off, Shane.
Yeah, I was trying to figure out where it wasn't quite right. Location.
I think the
What is it?
longitude is 105. Actually, that's close enough. It looks like. Yeah, that's close enough. I
Supposed to
misread
be
it.
40, right?
That's supposed to be
240.
40, and it was 39.9. And
Yeah,
I'm an
it
old guy,
kept
so
doing
I got
that.
confused
See?
by that.
It just did it again. I hit enter and it's like, no, you mean this. And I'm like, well, for 100th of a whatever. Fine. Fine. But
Brother knows what's best
elevation.
for us.
Elevation 4,300 meters, maybe? I don't know if that matters at all. So I went to for everyone watching, you can just do search stuff, and I entered 39 a query, and it auto focuses, right? So you can find where it would be. And I have the ground turned on, but you can see it's right about at the horizon, theoretically being occluded by a faraway mountaintop if it wasn't Stellarium's typical ground, right? They just put this stuff in there. And again, with refraction, with no refraction, with refraction, and up here is the angle, which is close to what Mike had, but it's not quite exact because I'm in a slightly different spot on this celestial sphere, and I can't quite get it to GPS right. But if we can, if we can see, it's 233, so I think it's within an arc minute or so. It's good. And then the main point is that once you line it up, and you can, we're using this star, but you can theoretically do any star for any location, right? As we were saying. And then the prediction with the math is what you're looking at, and how this is always alt adds is your flat Earth prediction. And then when you go, oh, actually pretend that I'm on a globe again, and it goes, oh, well, we'll just move that right up, and it'll put it back to what is almost exactly the globe prediction, right?
I found a copy of your book on eBay, Mike, for $22. It's not bad.
I think that's probably $8 or $9 cheaper than Amazon.
Fuck yeah. So there you go. So
Make sure they give you free shipping though.
yeah, there's 2 with free shipping. But yeah, so hell yeah, brother. I definitely gonna have a physical copy of your book soon.
Hey, Dr. Mike, have you tried doing a reading of the mountain during the day?
I can barely see these, or I can barely record these stars at night. So I think in the day there'd be so much light I'd never be able to pull it off unless I use something like this, the sun or the moon.
What about
So
just the
I'll
mountaintop?
just the what?
Just the mountaintop?
Oh, the mountaintop. I've never tried. What if I measure that with a real theodolite? I know it's not going to give me a true reading, and it's going to vary from day to day. And I don't remember who requested it, but they wanted me to take a real theodolite reading, and my son and my stepson-in-law's dad is in the construction business, and he's going to loan me one. They're going to bring it to me by Saturday, and theoretically on Saturday, um, we're supposed to have clear enough weather that I can pull it out off. It's literally been cloudy every day since I shot the stars on Blodgett Peak. So I haven't had a chance to do any experiments for a couple weeks now. And but anyway, if it's clear on Saturday like predicted, I'm going to shoot every peak and find out what it says the elevation is. And what I'm going to report to you guys is the real elevation as reported by the theodolite. And then I'll also tell you what temperature, pressure, and relative humidity was so that you can calculate whatever bogus corrections they have for that if you want to know that. But the really cool thing about the celestial theodolite is it's dead on every time with no corrections of any kind. No theodolite, no real theodolite can accomplish what that is accomplishing.
How awesome is that?
Dude, totally awesome. And then is tonight's talk mainly about your observation or your test, or are we asking personal questions as well? Because I've got one.
It's all questions and answers. So ask anything you want an answer to.
All right. So, I was present when you basically announced I'm a flat earther, and it was exciting. I could hear kind of joy in your voice, and like for me, I'm 3 years in to saying I believe in biblical cosmology. I believe we live on a stationary topographical plane, and everything is optical in the sky, like the luminaries, the heavenly bodies, they all appear to match the globe because that's how they made the globe. So my question is, have you felt just a overwhelming just rush of peace, knowing the truth of a piece of the truth of our realm? Because when I realized that when I have coffee on the back porch one morning, the next morning when I have coffee on the back porch, I haven't moved 1.9 million miles through space. It feels very good to me to be stable, stationary, and fixed. And I just wondered, what kind of peace or what kind of feelings did you have once you concluded what you concluded?
So that was probably fear you heard in my voice, um, because I realized um, the globe Earth null hypothesis cannot be refuted, which means the globe Earth is false and the flat Earth is true. So now my everything I believed about the Earth, everything that's been indoctrinated into me since childhood and on my parents before me and my grandparents before them, all of that's a big lie. But like all of you, um, over the past decades, I have discovered that we've been lied to about one thing after another, and I've had the peace that passes understanding for a long time, but I'm getting more peaceful now that I know ether is real, Earth is actually flat. Um, we had so much before that, like when the Bible tells Abraham, your your children are going to be more, your offspring are going to be more plentiful than the grains of sand on the seashore. Well, at the time God told that to Abraham, there were like only 6,000 stars that people could identify by looking up, and for thousands of years, it looked like that was a false statement in the Bible until Galileo invented this telescope, or some people say he stole that from somebody else. But when they first turned this telescopes on the stars and realized, oh, there really are an uncountable number on there, that just confirmed what the Bible said all along. So the Bible's showing itself true all along the way, whether you believe it or not. And the more things I find out are true, I guess the more peaceful I get.
Man, that's a fantastic response. I appreciate you sharing. I gave my life to the Messiah 15 years ago, and I got a certain level, I mean, a great level of peace and understanding of who I was in Him and how it all kind of operates, living a kind of not a subservient, but like subdued to His will, or asking daily for the Spirit to fill me and show me what You would have me do, Father, is so much better than let me be God of my own life and let me make all my decisions. Well, anyway, when my friend told me 3 years ago that he didn't believe outer space, the narrative of outer space as told, is real. It threw me for a loop, but I found ether cosmology and Witsid and some different folks. And, I woke up pretty quick because the deal with me is I've got, 3 kids and a fourth one about to be here. I didn't want to just tell them what I was told without investigating and pondering. And whenever I was told, the earth is enclosed, and kind of my buddy expressed biblical cosmology to me, I had cog dis at first. I kind of laughed. I didn't know what to think, but I took it serious because I believe there is a deceiver. I believe we have been lied to about many things. But letting go of the globe wasn't as hard for me as some, because I just want the truth. And I appreciate you doing everything you're doing and telling your story as well. My dad, he's 76 and has quite a bit of cog dis because the moon landings were really important to him, and he thinks they're real. And I told him about biblical cosmology, and he just thought it was a kind of like a cult and silly, and he didn't want to hear about it. It makes him real uncomfortable. And I had to choose to just not talk about it because my relationship with my father, is more important than arguing over the shape of the earth. But you waking up, later in your years after more years of indoctrination gives me hope that he'll get it one day. So thank you.
Same with my dad, dude. Yep. Same with my dad. So the
Yep,
cogniz is hard to get over.
it is, and for me, since I was born in the 40s, um, uh, I was heavily indoctrinated, and I was actively involved in the space program. I worked for Motorola, who built the transmitters for the moon landings, and I believed it all. And I believed it all my life. And the only thing that pulled me out of it is when I tried to figure out how can I help you guys um, prove your point, and that's when I came up with the celestial theodolite. And I'm probably way too familiar with the null hypothesis, so I know that's the only way you can actually have confidence in what you think you know, by just assuming you're wrong and then proving that you're wrong, which means you must be right. And then that that conveniently gives you a level of confidence that you're probably right. So in the case of the ether, I'm like 99.7% confident I'm right. In the case of the flat Earth, I'm only 99.7% confident that I'm right. But as Dr. Benefit Dr. Bennett will attest, um, that's all most physicists ever hope for, is to be that certain they're right.
Did you just say that you inadvertently converted yourself while trying to help us out? Is that how it happened for real?
That's what he said.
That's so awesome.
That's awesome.
You said it way more succinctly, but yes, that was a good summary of what I said.
Maybe you should talk to Dr. Bennett about how confident you are about flat Earth. See if he prove your null hypothesis right.
So I sent him a copy of what that PDF that I just gave Alan this afternoon, which is just a minor correction to the one you've been circulating before. And he and I are going to do a presentation together. He just wanted me to let you all know that, and just be patient with us old folks. We don't pedal as fast.
No
Roger that.
worries.
Oh,
We're
this
looking
is
forward
Eric.
to you guys as Prezi.
This is
Eric,
Eric.
you're next.
Well, I just want to say for people who are going to buy Dr. Heffern's book, be careful. The prices at Amazon, on eBay might be a little higher. Well, not a little. At Amazon, you can. I'm going to just round it off. Paperback, $15. Hard copy, $30, and the Kindle ebook is $6. So they might be charging double on eBay for the paperback version, $28 or something. So just be careful. Check the prices before you place your order.
I think
And
that's
Eric brought up another good point: is make sure that they're describing it as the hard cover for $30, because those prices he said, that should be the actual prices from Amazon. And if you have free shipping, then that's good. And all three books should be completely free. Borrow using Kindle Unlimited if you want to go that route.
Quality info.
I told I believe that's what Dr. Parks obtained your book, because he has Kindle Unlimited. I told Dr. Robert Parks, astronomer, about your books, and so he has a ebook version of it.
Then for anybody who wants to do the ebook version, it was only the luminous ether. When I got to that one, that's when I had discovered all the ways to defeat the things Amazon does to cobble up books. So that's the only one that's really good, that can handle dark mode. But it handles it as good as Amazon can handle it. The others are just horrible in dark mode, because all the equations are black equations on a white background, and there was no way to prevent that. I'd upload them so they'd work right, and Amazon would just change them all. And so the ebooks are not as good as the hard copies, but they're adequate. And the third one is the most adequate of them all.
Hey, thank you. I have to go get my little one down, and my phone's at 2%. I just wanted to say to everyone listening on YouTube and here in Discord, I can't thank y'all enough for your bravery and your hard work researching, communicating in love what you think is going on. Because what's amazing about the friends here is we may have differing opinions on many things, but rarely do we get argumentative or throw fallacies or ad homs or personal attacks. Like, it's not about that. And a lot of you truth seekers have been under fire, we all have, and attacked and called all sorts of names and just belittled. But seeking truth is always worth it. Truth is powerful and wonderful. And I mean, I don't know, just your story, Dr. Mike. I feel either a lot of the spirit or a lot of emotions just coming through me right now about how beautiful this whole thing is. So thank you, and I'll try to pop back on if I can, but if I don't, peace and love.
That's a great point, man.
Later, JTZ.
Here, I get sick and tired. Sorry, yeah, I get sick and tired of debating and I don't want to insult Glober. I mean, as fun as it is to mock and insult Globerzers, I don't want to do that here. So when I'm
Mm.
here, it's really refreshing to hear from people like all of you who are just sharing your own experiences. And yeah, it is very refreshing. So I really appreciate everyone here talking and sharing their story.
I appreciate it, brother. Your feedback, and I don't know if you've seen my channel, YouTube / at Run Boston Bear. I have a lot of interviews, and I generally just try to run it chill. Yeah, and I'd like to have you on, or Dr. Mike, if you want to talk more about what you've observed. You're welcome to do an interview with me. That'd be super fun. And I want to just shout out to Galatrax real quick because he helped me change my vocabulary from glober, like demeaning glober, to our globe friends. And I know there's some, paid shills and trolls and actors and stuff, that people that are just absolutely there to disrupt conversations. But I generally just try to position myself that they don't know, or they haven't been set free from the lie yet. So I show them as much grace as possible, even when they're attacking. I'm like, if they really knew deep down the truth, they wouldn't be acting this way. And so it helps me to stay calm. It's a little trick for y'all, but yeah, I'll try to hop back on, but y'all carry on. I'll be listening.
Send me a DM, Run Boston Bear.
Absolutely.
And so I'll
I could.
be, I've always tried to be very respectful. And this time I was probably overcome by annoyance with Rue for sending surveyors to my house. But I'm
Oh,
gonna go back to my calm demeanor, and I'll try to call them our globe friends.
Nice.
well, Dr. Heffron, did surveyors actually show up at your house?
That was a real picture he had of the real sign in my front yard, so I presume so. That was a
Oh,
gift from one of our volunteers, because obviously we cannot rescue all these dogs without a lot of help. Even with the help, it's a full-time job for me and my wife. We both put in somewhere in the neighborhood of 40 to 50 hours a week rescuing dogs, and we depend on the volunteers to clean up, to walk the dogs for us, to sweep up, to give them water. I do all the feeding, but the volunteers do a lot of the rest of the work. And one of
well,
the
yeah, that's.
volunteers gave us
Mhm.
that sign that he had a picture of, and I give him credit for blurring out the numbers. I um, I
Oh,
don't know. I think he was trying to do the right thing,
hmm.
but the fact that he was so insistent of his point of view, and it was like he was
Hmm.
purposely trying to
Well,
misunderstand, that made me
hmm.
doubt him.
Okay. Oh, now, yeah, if we know where you are, we can get autographed copies of the hard copies of your book. Okay, I'm
Y-
joking.
I
Sorry.
I would be happy to autograph a copy for anybody who wants one, and
Mhm.
I actually have um hard and soft copies that you can just tell me if you want me to say something specific, tell me what you want me to say,
Oh,
and tell me where to send it, and I will do it.
oh, that's very generous of you. Of course, reimburse you for the cost of the book and postage. Usually, this is not that important, but if I get a autographed copy, they might use my first name or last name, but I also like the date, just as a sort of a remembrance of when it was signed.
Yeah, and I usually don't date them. So if you want to
Mm.
date, tell me that. And if you don't tell me what to write, I'll usually write your name, and then underneath that I write always seek the truth. And then
Oh,
I
okay,
usually
that's
sign them
good.
Dr. Mike. Yep,
Nice.
I usually sign them Dr. Mike, but if you want it signed Michael or anything else, I'll do that too.
Oh,
So I consider you all friends, and you definitely made a convert of me. And I think we're kindred spirits because we all realize we've been lied to, and we're all seeking the truth as best we can.
that's well said. Yes.
I,
Um,
Yes, thank you so much, Dr. Mike. I am looking forward to going out and trying to do some celestial theodolite observations occulting stars near me. So see if I am far enough away from the mountain that is right outside my town.
That will be
Now,
such a thrill when you do it, and
mhm.
you can actually know in advance how it's going to work by predicting the flat Earth elevation from your location and the globe Earth elevation from your location, and as long as there's enough difference, you're far enough away.
Dr. Mike, I just want to say thank you in case I don't see you. I'm at the gym right now. I'm about to put my phone down, but thanks for everything, brother. For your presentation, and yeah, I look forward to occulting stars, black peaks out here in Vegas myself.
Loose
I hope
sentiment
everybody tries
received.
that. I really hope everybody tries occulting stars because you don't need a telescope, but binoculars and a stopwatch should be good enough. And that's a real thrill when you see for yourself that really is the flat Earth prediction.
This is very fascinating. Could one use a telescope instead of a theodolite?
So
Great
what I want to
question.
emphasize is do not use a theodolite, the a theodolite ever, unless you just want to mess with the our globe friends.
Mhm.
They think you have to measure it, and you don't have to measure it. It measures itself. So all you need is binoculars. I personally use a little sea star telescope, um, and I just set it up for time lapse and let it record them, and I look at them after the fact. So a telescope is definitely all you need. The important thing is you need to know what time the peak occluded the star, and you don't even
Mhm.
need you don't even need to know what the star was because when you see it's the correct elevation, Stellarium will tell you that's the star you just saw occluded.
It's a good thing we have Stellarium. There's also some other ones but Stellarium is pretty good.
Yep, and the only requirement is that you be able to turn correction off. So you can use your favorite astronomy tool. It doesn't need to be Stellarium. I use Stellarium because it was free for a Chromebook, and I do everything on a Chromebook because I've been watched by Big Brother and the Deep State my whole life, so that doesn't
Mhm.
bother me at all. I know they're doing it, so I don't even try to hide from them. I want the convenience of it automatically backs up everything I do.
I think some of us are there as well. Maybe if my channel is my name and I never had whatever, you know, I might be in that boat.
I mean, if you're not on a watch list, are you really a truth seeker?
Like you can't be my friend unless you're on like 3 watch lists, right? That's
Yeah,
probably where we're
I'm
at.
I'm pretty sure I'm on a watch list, but I think you could find out if you file a Freedom of Information Act. But well, I don't know. All those people might that handle those have been fired recently. I don't know.
They may just put those in a bin, and anyone who requests the list gets automatically put on the list.
The li-
Comedians in the world are on the watch list. There's CIA 1,000-page documents on them.
Mhm.
Well, anyway, any other questions for Dr. Mike while he's here in the community and fielding questions?
Let me just say it's not a question; it's just a comment. I obtained a few months ago the hard copy of the Luminiferous Ether book of Dr. Heffron's. I recommend getting the hardback. I mean, the paperback is good. The color, you get color in both, but I have the hard. In fact, the hard copy has been on my desk here in one position or another for at least 3 or 4 months. So I recommend getting the hard copy. I mean, the hardcover hard copy, to be more precise.
Awesome. Well, if there's no further questions,
Yeah.
thank you so much for your time, Dr. Mike.
Everyone's homework is to come up with one brand new original flat Earth proof, like Dr. Michael, and get it to us next week.
One brand new, mutually exclusive proof, argued in the form of a null hypothesis.
Yeah, of course, everyone must bring one to the table. We'll have like a potluck of null hypotheses, and we'll see what happens.
That's awesome. Yeah, so if you have mountains or something like that in your area, hit this up, man. Let's stack some data points there, and then you can email them to me at AlanSpaceAudits@gmail.com, and we could make a nice little collection piece, do a little collage or something, a little follow-up. So there's several tutorials now on how to do it. So I expect everyone to do their homework, like Shane said, or you're all fired, or whatever happens when you don't do homework.
I think social shaming.
Social shaming, yes. Your Flat Earth social credit score will be lowered significantly.
Yes, there you go.
Yep, will do.
And then if anybody has any,
Yep, later, G.
if anyone has any afterthought questions, just go ahead and send them to me. If you're not already a friend, you can send a friend request. If you don't want anybody to know that you asked that question. But I don't think anybody here is embarrassed to let everybody else know what they don't know. So you can handle it any way you want, but I'll be happy to answer any questions that come in after the fact.
I do like that you cater to the closet glober, though. The people who are in the closet and don't want to know, maybe send a discreet inquiry to someone on the same side who won't judge you. I do like you filling that role. That'll be nice.
Like if you want to send me a message in a back alley and leave some
Like, you could just send me an anonymous question and I'll answer it anonymously, no matter.
if a carrier pigeon drops by. All right. So what do we got going on tomorrow, Shane? We got Taylor's debate. Big debate tomorrow.
Even better than TikTok.
Yeah. Taylor's going to be debating Grayson Hawkson or something like that on the origin of life.
Nice.
Over on Earth Awakenings, and Gally is going to moderate.
Awesome.
Taylor, I see your mic coming off of mute and going back on mute. I'm so confused. Would you like to chime in? There's no words coming out.
Just know it's expected. I think she's broken.
Okay, it's not just me. Gotcha. All right. This is the reverse hot mic. She can't open. You can't hot mic. All right.
Pretends to talk to you.
Tomorrow at 8 p.m., Taylor's going to be debating critical base theory, aka Grayson Hawk, on the origins of life over at Earth Awakening. So 8 p.m. Tune in for that. And then Friday, of course, will be some sort of community event on Twitter. So stay tuned for that. And then Sunday will be Glowbusters. Then Tuesday, Shane's going to be presenting something on Eratosthenes, I think.
Oh, yeah. I would just do Glowbusters and then Ether Cause instead of Ether Cause and then Glowbusters. That's cool.
Yep.
That works. Yeah, it should be fun.